Hello, and this is a recap of the Internet Security Part 1. So here we go. So if we were doing the session, we might start by looking at all these different words. These are all words that are related to IT security, and there's some really good ones. So traditionally, I would get you to introduce yourself. I would get you to pick one of these words, and I would then have you either say what it means, or if you're not sure, a fun alternative is to make something up, because there are some absolutely ridiculous words associated with IT security these days, and it's quite good fun to do that. So let me go through some of my favorites. So we've got phishing, spelled with a PH. This is the process whereby people send out a broad spectrum of emails to try to hook somebody in to some sort of scam. It's phishing because you don't know what sort of who you're going to catch. It's very broad by definition. Down there in the bottom left-hand corner, we've got spear phishing. Spear phishing is the same idea, but it's more targeted. So when you're, I believe if you're spearfishing, you actually see the fish and you try and catch the specific one. So this could be targeting either a organization or targeting a specific individual within an organization. We've got ransomware. I'll probably talk more about that in a moment. We've got smishing. Smishing is again based on this phishing term, but it's a contraction of SMS, so text message phishing. Keyloggers, they record all of the different, as you type things into your computer. A worm is a sort of a virus, but the clever thing about being a worm means it can spread itself. It doesn't need any interaction. So we've got viruses. So viruses typically do need some sort of interaction. They need you to click on that exe or open that spreadsheet with a macro and run something. So viruses don't typically run themselves, whereas if something is a worm or wormable, it will run itself. Spyware, that's a contraction of spying software. So that's computers that, again, keyloggers would be an example of one. It might turn on your webcam and record you. Adware, all these words ending in ware are software, so that's advertising software. So you may have seen it before where your search engine gets, or the default search engine in your browser gets overtaken. Probably not the right word, overtaken, but taken over, sorry. And you start searching for something, expecting to probably go to Google, but you get some obscure search engine returning the results, and the way the hackers are making their money there is through being paid by that search engine to get them traffic. We've got malvertising. That's advertising that's malicious. So websites these days don't tend to necessarily, they might go to Google and they might say to Google, because they're the biggest advertising network on the planet, they might say to them, I've got a couple of spots on my website where you could place an advert. And the people, there's often some criteria they can say, I don't want anything to do with, say, the military, or, if they, there's often lots of filters that you can choose on them. However, what some people do is they will then embed malicious images that then get distributed and displayed on people's website, and they've done something to corrupt the image so that it can cause your computer to get infections. You might not be able to see it properly because I'm obscuring a couple there. So social engineering and crimeware. So crimeware is another generic term for all this sort of software that's illegal. Social engineering is the process of trying to socially, it's like if you phoned a company up and pretended to be an engineer or something like that, you're socially engineering the person on the other end of the call to disclose some secrets, and that could be done via emails or phone calls or Zoom calls or anything like that. A drive-by download, that's the process whereby you it's basically a lot of the way that ransomware works. It's the process whereby you do not instruct your computer to download something, but somebody clicks on a link, and in the background there is a download that's hidden from your site that installs some software on your computer, such as some ransomware. Okay, a Trojan. Trojan is following the Greek myth. Hopefully it's Greek. I think it is. And it's hiding one type of software inside another. So you think you're using I don't know, Photoshop for example, but actually it's stays running in the background and it logs all the keystrokes. And then finally, my favorite one, just for the pure silliness of the name, is the poisoned watering hole. This is very much still running along the phishing analogy. And let's imagine that you're trying to target this company over here, and this company have excellent security, and so you can't get in. And let's say they were an agricultural, a farm-based. They supply farm products. Well, then there might be a website that's very popular with farmers to go to. Yeah, and so if you could attack somewhere and implant some technology, implant a virus or a worm on a website where people are going to frequent that belong to the industry or the specific company that you're trying to attack, then it's said to have poisoned their watering hole. The watering hole meaning a website that people from company X that you're trying to attack might visit, that might have some weaker security. So some great words there. Rootkit, by the way, I've just noticed I haven't spoken about that. A rootkit is a piece of technology that installs itself so deeply on your computer that it's almost impossible to uninstall it. It really hides itself deep down. It would look to all intents and purposes like it's been removed, but it can it's sort of living maybe almost in the BIOS or something like that. And the only really way you can get rid of that is to completely wipe the computer. So it's quite a bad state of affairs if you get any rootkit technology infecting your computer. So let's just sort of see where we are and why. Now, this is actually the current where we are in society. And I used to have a slide here that sort of talked about ransomware and how prolific it was becoming. But then I discovered that a couple of years ago that this is actually now a thing. Ransomware as a service. So if you're thinking of future business opportunities, you could take a franchise in Subway, and set that up, or instead you could become a ransomware as a service business provider. Absolutely ridiculous that this now exists, but it does. And basically the way it works is like this. So let me show you that, if you're seriously considering this, you've got some options. I'm probably going to murder the pronunciation, but the Sodinokibi has the greatest market share. So if you've got to think about, they're probably the best providers of the software. And here's just the top 8 ransomware software from 2020, I think this is last year. And you can see there, look at that, £81,939 was the average amount that people paid out for ransomware last year, which I think has linked to the price of Bitcoin. I think for most of last year that was the price of 2 Bitcoin. So absolutely crazy. So let's see if you were to set up this idea, and this is sort of a bit of a fun idea. I'll move myself around slightly so that I can get. But this is actually existing in the world today. It almost blows my mind. So over here on the left hand side we've got the developer. Okay, generally probably somebody very clever, and she's written some code that can be used to exploit people's computers, but she doesn't want to do it herself, so she wants to employ affiliates, like people part of a franchise that are going to do it from them. And all they really need is they just need their own server somewhere sitting there. So step number 2 here, this is where the person that's the affiliate has their server, and they're going to upload some information to it. Okay, now then, what they do, what do you do? What is your job if you are an affiliate to a ransomware service? Well, what you're trying to do is get people to click your links. You want to get people to click your links. So here we go. Position number 3, you email your link to your victim. Okay, so you've identified your victim. I'll pop me over here for a second. And you get them to click on that link. And then what happens is something we've mentioned earlier on, that a drive-by download occurs. So in the background onto their computer, some software is downloaded, and that's stage 5. Now what that software starts to do is it encrypts all the data on your computer, and on the victim's computer, and not only does it encrypt all the data, it looks for other computers on the network, hoping to find a server maybe, and it encrypts all the data on the server. Then it tries to find the backups, and it's a beautiful thing for ransomware if it finds the backups, because it encrypts all the backups. And what it does, the beauty of this is, from the bad guy's perspective, is they're taking all the data off your computer in a way, because they're making it so that you can't use that data, but they're just encrypting the data. So the beauty of it is they don't need lots of storage space. All of the data stays on your computer, but it's just been zipped up. It's essentially, you know, when you zip something up and you can attach a password to it, that's all it's really doing. And that password here gets sent back stage 6 to the affiliate. So the affiliate holds on to that password. Okay, it's essentially what it is. It's just a very good, a very secure way of zipping something up. And then, so what happens then? So then the victim, now often the victims, especially if it has encrypted their backups, they do end up paying. And this is the truly bizarre thing, is that ransomware software actually has a very good reputation for restoring your data. I've even heard people talk that, I remember hearing somebody say that they wish their IT support team were as good at support as the ransomware software people have been. And I suppose that they've got to perform a job, they've got to perform a service of some kind. They've got to give you back your data, because if it was all seen to be a scam, then people wouldn't pay. But because they've got this reputation for restoring your data, and I'm not advising anybody to pay it, but the chances are it will come back if you do pay, because they want this proliferating. They want to carry on earning money, and if the whole thing was just seen as a waste of money, then the industry would die very quickly. So that's what happens here at stage 7. The poor victim pays some money. Now the developer at the start, she was very smart, and so she would probably put in some automated part of it where some money goes to the affiliate and some money comes straight back to her. Okay, and then once that's happened, then the affiliate, the franchisee, sends them back the key to the victim so that they can unencrypt their data. So obviously the best way to, the two ways out of this are not, stage 3 or stage 4 in this case, because we're going to receive these emails whether we like it or not. But it's not clicking on the links in the emails and understanding how to spot them, which is what we're going to look at in this course. Or making sure, so stage 6, when they're encrypting all the data on your computer, making sure, obviously we don't want to get to that scenario, but if we do get to that scenario, we need some offline backups, and offline is the key there, because if they're offline, then the ransomware can't get to them to encrypt the backups as well. So hopefully that makes sense. And this is just like the state of the industry at the moment. This is happening to more and more computers. There was the pipeline in America that recently got shut down because of ransomware. It's an ever-growing problem. So one of the first and best ways that you can sort of hopefully prevent yourself from coming into this situation is to do with passwords. Okay, so here is just some fun examples, some of the worst passwords from last year from database hacks. Let me put myself down here now. So obviously some of these websites that start to enforce good password management or good password protocols, such as the uppercase, lowercase, special characters and things like that, they would have such random passwords that they probably aren't going to show up in a list like this. So this is probably from websites that have poor password protections and let you just pick whatever you want. And so you can see the most common worst password used last year was 123456, where that was found in over 2.5 million databases. Absolutely ridiculous. Picture one, that's a newcomer there. That you can see it wasn't in the charts last year. Sounded a bit like a DJ. Not quite sure why Senna is there. Maybe something happened in 2020. I don't quite know what that refers to. Here's the next 10. So they're starting to get a tiny bit more cryptic. If anybody knows what this ARM431 is referring to, I'd love to know why 90,000 people have chosen that as their password. I don't really know myself. Now, we all know that password reuse is a really bad idea. but I think we often miss the reason why it's bad. So lots of people make the mistake of having one password, or maybe 2 or 3, but they reuse these passwords over and over again. Okay, and they come to the conclusion to themselves that A, they've not been hacked, so it's not a big deal, and they come to the conclusion that, well, I'm not going to go around telling the world what my password is. So if I reuse it from site to site, nobody really knows because I'm not telling people what my password is. And this is the fundamental problem, is that people don't actually understand what the problem is. And the problem isn't them themselves losing the password. The problem is the websites we give our passwords to may well lose them. So there is a website that we're going to go and have a look at in a moment called haveibeenpwned.com. And this is a great word, the pwned. Okay, there's a little definition here of where that comes from. So, you know, the kids these days, they say owned if they beat somebody in a computer game. They've been owned. And somebody misspelt it apparently on a World of Warcraft map. And instead of writing owned, they wrote pwned. So that became a word. And this is quite a few years ago now. I mean, I've been using the Have I Been Pwned website for at least 6 years. So it's not that new a word. And we can see here on the left-hand side, this is the current list of largest breaches. So I don't know what collections number 1 do, but I know about Verifications.io. So this company verify people's email addresses, and they lost every single account. They were hacked, and they lost every single account that they had in their database, and that was quite a few. That was 763 million people's details. So we are talking numbers that are just almost beyond comprehension. So this is the sort of the current, I don't know if it is it a top 10, 1, 2, 3, 4, 5, 6, 7, 8, 9. Yeah, so this is the top 10 largest breaches that the Have I Been Pwned website. And what the guy does, so we'll bring it up. So here's the website. Here we go. So here it is, haveibeenpwned.com. Okay. And let me just show you who this is about. So this is a guy called Troy Hunt, very American name. Hi, I'm Troy Hunt. And he is a Microsoft Regional Director. This is a very well-established, well-known website. It's been running for many years. Like I said, I've been using it for at least 6 years. And what he does is he goes around and he collects all the databases that hackers have once they've hacked a website and thrown them onto the internet. He goes about and hoovers them up and then sort of makes the contents. You can check whether you've been involved in a breach. So if I was to put my email address in here, okay. So look, I have been breached 4 times, my data has, okay. So we can see that a website called Canva, so good for producing graphics and things like that, they lost my email address, my geographic location, my name, my password, and my username. So thank you, Canva, for that. MyFitnessPal, they lost my email address, my IP address, my password, and my username. Going back a little bit, Patreon lost a bunch of my information. And in 2013, Tumblr lost my email address and password. Now, here's the problem. The problem is, if I am reusing my passwords, if whatever password I used for Tumblr, I use for my email address, well then my emails have just been hacked. And when people say their email address have been hacked, they almost never have been hacked, as in people trying specifically to hack you. What's happened is, you know, this guy, Troy Hunt, he's gone around and he's got my details from this Tumblr site, Patreon site, because the databases have just been thrown on the internet. So he's managed to get them. So other hackers could just as easily get them. And then they can see my email address and they can see my password and they can say, well, does this password fit this email address? Or does this password unlock my Vodafone account or my electricity bill or my phone or any other of my, my PayPal or anything like that? Yeah? And that's how people get in trouble. So it's not that you will lose your data, it's that the people you are giving your data to is going to lose it. Okay? So, let's go back to here. So I've been doing this for a number of years, as I mentioned, and I just want to say quickly that the problem isn't getting any better. In fact, it's getting a lot worse. So in 2018, this was the top 10 or however many, top 15 here. So in 2018, the worst affected was MySpace. Okay, so MySpace was very popular at one time, and they still have a lot of people's accounts information, and that did get hacked, I think, in 2018. So they lost 359 million people's details. So just as a reminder, now the largest breaches are double that at 770 million. Okay, and that, if you go down, so if we go back in time to when I first took a screenshot from the website, 2015, well, Adobe were the worst culprits then. They lost 152 million people. But look at the bottom of this list. Again, I think it's slightly more than 10, but the bottom of this list, we've got 855,000. So the bottom of the list now, 2021, has 234 million people's details. The bottom of the list in 2015 had 855,000. So you can see the process is getting worse and it's getting faster. More people are getting hacked quicker. More people are getting hacked than ever before. Okay. Now, so this is a screenshot that I've had for a couple of years. I haven't updated this one because we've just seen that I'm actually part of 4 breaches now. But when I first took this screenshot in, say, 2017, I think I was 2. Okay. Now, I say few, it's okay, because I had an individual password, and I do have individual passwords on every one of on every website. Okay. But it does pose a slight problem if we want to have individual passwords on every single website. And of course, the problem is remembering the passwords. So, the current expert advice is to use a password manager. Okay, LastPass, I think, is probably the best well-known password manager. They have recently started charging a bit more for their service, and so I actually use one called Bitwarden. But there are lots of these about, and so I will refer to LastPass because although they might be, I think they're like $2.50 a month, so $30 a year, so that's what, £25, something like that. But they have been tested more rigorously than almost any website on the planet, because in some ways they are holding the keys to the kingdom. I'll explain how it's not quite that in reality. It's a bit safer than that, but they have had people check out the maths behind the protocols they use on their website. They've had hackers. They pay for penetration testers to try and hack into them. They've done everything they can to make sure your data is secure. And nobody's ever found that it's been incorrectly implemented. I couldn't think of the right word there. So just so we understand, because every time I teach this session, the one thing that people always ask is, well, what if LastPass or a similar one gets hacked? Aren't you then in more trouble than you would be for just losing one password? And I think it's important to understand. So the reason that LastPass is called LastPass is because that's meant to be the last password you need to remember. Okay? And you do actually need to remember these passwords. There is no "I've forgotten my password" button. They do have some methods that you can take some piece of information from the LastPass site and store it safely, and you can get in if you do lose your password key. But by default, there is no "I've forgotten my password" button. And if there was "I've forgotten my password" button, then I wouldn't want to use that service, because it means that a hacker could press "I've forgotten my password" button and get in. So you have to put on your big boy pants a little bit with these services and take some steps for providing some of your own security. But at the same time, the payback you get is a much more secure environment for yourself. But it's just let me just point out how it works just with one quick example. So say Facebook, for example. LastPass remembers my Facebook password. And to unlock LastPass on my computer, I type in my LastPass password, which should be a very strong password, which we'll have a look at momentarily. So I type in this very strong password, and LastPass saves my Facebook password. But if it just saved my password to LastPass, to the cloud, then that would be really quite insecure. Because if somebody could hack into LastPass, then they just get my password for Facebook and all my other passwords. And that wouldn't really be a particularly good solution. So LastPass, they already thought of this. So what they do is they take my LastPass password and my Facebook password, and they encrypt my Facebook password using my LastPass password. And they don't just do it once and save that, because computers are so fast these days that a computer can do that in, say, 1,000th of a second, let's say, or even faster, 10,000th of a second. Okay, it's probably even faster than that, but for the maths, let's say 10,000th of a second. And so what LastPass do is they don't do it once or twice or 10 or 100 times, but they do it 15,000 times. They encrypt my password. Okay, so they encrypt it again, blah, 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 15,000 times. They encrypt it so many times that it physically takes the computer a second or so to run the procedure, because it's doing it so many times that even a super fast computer, let's say it could do it 10,000 times in 1 second, well, if it encrypts it 15,000 times, it's going to take even a computer 1.5 seconds to unlock that. But that's good, because that means that if somebody's trying to hack in and they have a guess at my password, it takes a second for the computer to say, no, that's the wrong password. So that means they can only do one guess a second, which in the world of hacking is just so ridiculously slow as to be not worth doing. You know, they can do 60 tries in a minute. I mean, you know, it's ridiculous that you just never could hack at that speed. And we'll see in a minute the sort of speed you need to be able to go at to hack passwords, and it's orders of magnitude faster than that. So yes, so LastPass never store my actual passwords. They just store an encrypted version of my password. And even if somebody could hack into LastPass and they downloaded all of my data, they would just get these encrypted blobs, they're often referred to. And that would still be no use to them whatsoever unless they knew what and LastPass never store my password. Like I said, I can't press a button and get LastPass to send me back my password. So LastPass never store my password anywhere, and my Facebook password is encrypted against my password 15, 20,000 times. Okay? So even if they were hacked, you would still need to know my LastPass password too, which you would never use, just to be clear, anywhere else. Your LastPass password or your password manager is secure, only ever used on one device. And finally, if you don't want to go the whole hog of having a full password manager, then maybe, you know, a very good alternative these days is getting your phone to remember your passwords for you. You know, the protection that Apple have built into iPhones and that Google have built into Android operating system, as long as they're fully patched, which means fully up to date, all of the, you know, any updates have been applied. Apple and Google, you know, these aren't small players in the world. You know, the technology and the security is, you know, literally the best in the world. These people employ, you know, the best programmers in all of the world. So you can be certain that the software and the secure has been implemented very securely. So let's have a quick look at passwords. So what makes a strong password? So if I was to say to you that my password was one number long, just one number, and I wanted you to try and hack my password, try and guess it, what's the most number of guesses it would take you to hack it? 10 guesses, right? 1, 2, 3, 4, 5, 6, 7, 8, 9, 0. And lowercase letters, well, there's 26 of those, and there's obviously the same 26 uppercase. And then special characters, so those on your keyboard are all of the other characters, the exclamation mark, the quotation mark, the ampersand, all of those sort of things. There's 33 of those, okay? So this is why websites want you to, what they want you to do is they want you to use as many of these as possible. And it's because it makes it harder to guess. So let me just carry on with this analogy. So if I had a 2-digit password that was 2 numbers, then there was 100 possible combinations of that. Yeah? If I had 2 letters, well, that's 26 times 26, which is 676 possible combinations. Okay? If I have 2 uppercase, it's the same. If I have 2 special characters, well, that means it's 33 possible choices in the first slot and 33 possible. So there's 33 times 33, which is 1,089. Now, here's an interesting one. The last one here. So if I had a password that was made up of numbers, so there's 10 numbers, and lowercase letters, well, there's 26 lowercase letters. So that means that in either of those two slots, there's 36 possible combinations. So 36 in the first slot multiplied by 36 combinations in the second slot means there's a total possible of 1,296 possible combinations. Okay? So what I want you guys to have a go at doing is working out if you've got a password that was uppercase and lowercase letters. So either of these slots could be upper, just like this last one. So this was the 10 lowercase, the 10 numbers plus the 26 lowercase letters, giving us 36 possible digits that could go in the first column and 36 possible digits that could go in the second column. So 36 times 36 gave us that 1,296. I want you to work out what the possible numbers of combinations could be for this. If you had uppercase and lowercase, if you had uppercase and special characters, then if you went on to slightly longer passwords that were numbers, lowercase and uppercase, and then finally a 4-digit. And now I find this amazing when you work out what this number is. If you've got a password that consists of an uppercase, a lowercase, a number and a special character, so that's only 4 digits long, I think you'll be surprised at the possible combinations of just 4 digits. It's a bigger number than I would have expected.